So we left off yesterday by talking about the real versus pecuniary effects that firms can induce by changing their strategy. And we said the real effects is that they can change the industry's quantity, and that affects profits by the amount of the markup, right? If you increase your quantity, for every unit of markup you make more money. But you can also change the prices, which affects industry profits by the change in prices multiplied by quantity. Okay, now which of these effects would a social planner want to take into account? Andrew's not here. Anybody else want to say? Yeah, Julian.
So planners should care about the real externality, especially because the pecuniary externality is actually benefiting consumers.
Yeah, so they'll want to care only about the real. So here it's not just externalities. I'm taking all the effects into account.
Right.
But in general, they're going to take into account all those real effects, right? And so what would they want to try to equate to zero, Julian?
So they want to make the markup zero. Right?
What? Yeah, and a more general way of putting that is they want to make the real effect zero. So they want to say that, set that equal to zero, right? And how about a monopolist or a cartel? Austin's not here. Anybody else want to say what a monopolist or a profit-maximizing cartel would do? Yeah, Rishi?
Want to set both the real and pecuniary.
The sum of the two of them, right?
Zero.
Exactly. And so we can define a quantity called the conduct parameter theta, which is equal to the ratio of the real to the pecuniary effects. And under perfect competition or social optimality, what would this be equal to? Anybody? Yeah, Adam.
Well, because the markup would be zero, theta would be zero.
Yeah, theta would be zero, that's right. And under monopoly, what would this be set equal to? Somebody else? Yeah, Rishi.
From the previous section,
Yep.
here's the thing, you have MDQ is equal to negative QDQ.
Yep,
So numerator denominator equal, so 1.
exactly. And more generally, this thing is going to be equal to the ratio of the markup to negative of quantity times dq dp, which you can rearrange by just bringing this q over here and then dividing the top and dividing the bottom and multiplying the top by p, and you get the elasticity. So you get the markup relative to price times the elasticity, right? Which is here is the learner index, and under monopoly, learner index is equal to 1 over the elasticity. But more generally, this is a measure of the degree of market power. Yeah, Rishi.
When you say let conduct equal then theta equals x, what exactly do you mean by conduct or theta?
So this is just a parameter
Okay.
which captures the degree. So remember, we had all these complicated things. In fact,
Right.
I think you came to our office hours to talk about this. We had all these complicated things that could lead firms to have more market power effectively. It could be that there are fewer firms or more differentiated products, etc. This is one number that summarizes all of that.
Okay.
And it summarizes it through the extent to which the pecuniary versus real effects are taken into account. And so in some sense, you can think of everything we've studied as a way of getting a handle on what this number is. Okay. So let me talk about how the specific models we've been talking, or let's talk about how the specific models we've been going through fit into this. Can someone tell me what the conduct parameter is equal to under Cornell? Competition? Because remember that this thing is equal to theta, and do you remember what the markup relative to price was equal to under Cornell? Well, remember that under Cornell, price minus marginal cost is equal to negative p prime times the q of that individual firm, which is 1 over n of the total quantity. and therefore theta is equal to 1 over n. So if we add in conjectures, which I talked to you guys about informally, right, where the amount of quantity of the other firms might change when you change your quantity, that's going to increase the amount that firms expect the total quantity to react to a change in their quantity. And so the conduct parameter is going to change depending on this. So if I expect that other firms are going to increase their quantity when I increase mine, they'll retaliate against me in that sense, then this conduct will get higher. That's like a way of doing collusion, right? On the other hand, if I anticipate that when I increase my quantity, other people reduce their quantity, this will actually become, this will be a negative number. And in fact, if this is equal to -1, then we get to effectively Bertrand competition, or theta equals 0, because if I expect that other people hold their price fixed, that means that if I increase my quantity, other people reduce their quantity to perfectly offset mine. Under differentiated Bertrand, this is equal, price minus marginal cost over price is equal to the inverse of the residual elasticity, right? Which is the derivative of, which comes out of the derivative of your quantity with respect to your own price, right? Which we can express in terms of the derivative of the total quantity with respect to the total price times 1, so we can multiply the bottom and the top of this by that, and then we can have a ratio of the derivative of the total quantity with respect to everybody's price changing, which will be divided by 1 over n, because your quantity is only 1 over n of the total quantity. And so what this turns into is theta being equal to how much the total quantity changes when the price changes, divided by n times how much your price changes, your quantity changes when your price changes. You can then, through a series of calculations that I won't go through in too much detail, derive this is equal to 1 minus what's called the aggregate diversion ratio. So the aggregate diversion ratio is when I sell one more unit of the good, how many units does everybody else in the industry lose? So if I lower my price, that's going to give me some more sales, but give everybody else less sales. And the question is, what fraction of the sales that I gained came from other people's sales versus coming from outside goods outside of the market? That's the diversion ratio. And this theta is going to be 1 minus that. Now that's very natural, because we said that if goods are very good substitutes for one another, that is, my marginal sale comes overwhelmingly from other people's goods, right? Then we're going to have very close, tight competition. On the other hand, if my sales mostly come from outside goods because the goods are not very competitive with one another, then D will be low and theta will be high, will be near monopoly. Okay. And this theta, which depends on the diversion ratio, is not typically constant. It actually increases with price rather than being constant as it is in these other cases. Okay. So that's it for that lecture. Now we're caught up. Let's move on to the next lecture, where we're going to apply these ideas. Okay. To a very active area of economic policy, and one that I've been quite involved with, which is the control of mergers. So we're going to start by looking at stability in the Cournot model and how that leads to the comparative statics with respect to the number of firms and the benefits of entry. Then we'll talk about how competition will drive prices down to cost, as well as more general ways in which some notion of competition can drive prices down to cost. And we'll investigate some empirical analysis of the rate at which more competition will drive prices down to cost. We'll then talk about mergers in differentiated products industries and the concept of upward pricing pressure. And then we'll use that to talk about how mergers are actually evaluated in practice in the US and around the world, as well as some other common approaches to merger analysis and some of the challenges that merger policy and analysis face going forward. Okay. So remember that we said that comparative statics go haywire if an equilibrium is not stable. And now I want to talk about what's the right notion of stability in Cournot equilibrium. Well, remember our reaction functions. Remember how I did a little stability thing in those diagrams, right? And if those crossed in the right direction, then we had stability. And let me just take you through that logic. Imagine one firm increases their quantity, Qj, by a little bit. How much, Suel, how much will the quantity of firm I rise by or fall by when quantity of firm J increases?
Do you have the reaction function?
Well, let's relate it to the pass-through stuff we were talking about. Do you remember the notion of quantity pass-through?
Not entirely. But,
So quantity pass-through is if one firm that's like other than the firm in the market increases its quantity by some amount, how much does the total quantity supplied to the industry increase? And we showed that that was equal to the cost price pass-through as well.
the cost price pass-through. Okay.
So if we just call that the pass-through, so how would we figure out how much, if we have two firms, if one firm increases its quantity, how much will the remaining firm increase
So
their
we
quantity?
have the pass-through. We have the cost price pass-through.
Yeah?
Cool. So if Qj increases a certain amount, then you have the pass-through of Qj.
Yeah?
That's how much the Qi rises.
That's how much the
That's
total
how much
quantity.
the total one rises. So it would be that divided by like n.
No, it's just that minus 1. Because the thing is Qj is increasing, right? And then how much is Qi going to increase? Well, the total of Qj and Qi is going to increase by pass-through.
Okay.
And then you have to
you're assuming
subtract
that
the
two
1, which is the amount that Qi increased, Qj increased, right? Which is, well, this is even easier. Sorry. Well, I mean, this is also the slope of the reaction function, right? And if Qi rises as a result of Qj rising, how much is that in turn going to cause Qi to change, Christian? Just in terms of the reaction functions, how would you express that?
Would it be the slope of the reaction function of J?
Yeah, exactly. So the total amount
Oh, total.
is going to be the slope of the reaction function of I to J's change times J's reaction to I. So it's the product of those two things. Yeah, Mike?
Does this assume that originally Qj increased by 1? Because
Well, yeah, 1 times
Okay.
epsilon. You know, it's like a standard differentiation
Okay.
type of thing. Okay. So, Julian, can you see under what circumstances this is going to converge and under what circumstances it's going to go nuts?
So it should be assuming that Ra prime and Rj prime are both like, well, they can't be the same. Well, it depends on whether Ri prime times Rj prime is greater than Qj or less than Qj.
Yeah, less than 1, right?
Less than 1,
Yeah,
right?
yeah, exactly.
Whether
Exactly.
increasing more than.
Yeah, so if these are greater than 1, then you're going to keep running through this process and it's going to keep getting bigger and bigger and bigger each time, right? And if the product is less than 1, then it will converge, right? Now, it turns out that the monopoly's second order condition, that the marginal revenue declines relative to marginal cost, is always enough to ensure this. But in general, you just want to check when you're solving problems that you have stability in this sense that things don't spiral out of control. Okay. So one firm's increasing their production should always lead the total production to rise, and the amount that it will cause it to rise is the derivative of firm I's reaction function plus 1, right? Because there's the direct effect plus the reaction function, right? And this is the same for both firms because it's symmetric, and this number is the quantity pass-through, which I think we talked about before. Maybe we didn't talk about before. Did we talk about it in the earlier lecture? No. No, it didn't. Okay, we didn't talk about it. So this is the quantity pass-through. So I was trying to extract blood from Suhail about something I haven't even taught you guys yet. So this says if one firm's quantity increases, how much does the total quantity increase? That's the quantity pass-through. And the reason it's called that is because it turns out this is equal to the cost-price pass-through, which I won't go through. But the paper one of the papers in the references discusses this. So it turns out that if you run through all those chains of stuff, stability ends up being that the quantity pass-through is less than n over n minus 1. And the way you can see that is that you can trace through the logic. So you could say, imagine that there are 2 firms in the industry, and now we bring in a third one, and that third one raises its quantity. Well, how much is that going to increase the total quantity of the industry? Well, each firm is going to increase its quantity by symmetry by 1/2 of the total amount that it increases minus 1. Because 1 is the amount that the third firm increased it, and the other 2 firms are going to increase by half of that difference or decrease. To be consistent, this has to be the pass-through, the total amount that it increases has to be the pass-through of the amount that the other 2, that one other firm changes it, plus the amount that directly the third firm changes it. Okay, why is that? So I'm trying to get down to one firm being isolated, right? So there's the one firm externally that's increasing its quantity. Then that's leading the individual, the second firm to increase their quantity by this much. And now from the perspective of the third firm, I'm going to pass that through at the quantity pass-through rate. Okay, so then you can use this to solve out for things, bringing this to the other side of the equation and solving for rho Q, and you get that the change in the quantity from a change in an individual firm is the quantity pass-through over 2 minus the quantity pass-through. And more generally, it's going to be equal to the quantity pass-through over n minus 1 times the quantity pass-through. And from that, you can derive that things will not go crazy as long as this inequality is satisfied. And most importantly, this is going to be positive anytime you have stability. So that says that one firm increasing its quantity always increases the total quantity supplied to the market. Yeah, Bharat.
Was what happened there that a firm enters the industry and as a result, like those other firms, increase by 1/2 times dp/dq minus 1, and then as a result of that increase, like the other firms respond again?
Yeah, so that's how you would trace through the stability
Oh,
argument. Yeah. Okay, so if a new firm enters the industry, it's going to start with a quantity of 0, and it's going to raise its production from that point. This is going to increase the total quantity of the industry by exactly the same argument we just gave, right? If a new firm comes in and they raise their production from 0 when they're initially there to some higher quantity, this has to raise total production, and that increase in total production is going to drive down the price in the industry, and thus adding this new firm makes the industry effectively more competitive by driving prices closer to cost, right? And this is a more general feature. As the number of firms increase, the industry is going to become more competitive, and in fact, it's eventually going to get to perfect competition. And I want to take you through a simple mathematical example of that, like the ones that we've been doing. So again, imagine we have constant elasticity, symmetric, constant marginal cost. We know each firm is going to set price plus quantity times derivative price is equal to cost. So by symmetry, all the firms are going to have 1 over n of the total quantity. Rishi, can you convert this into an expression in terms of elasticities?
Sure. So, should I go on the board, or should I just do this?
Well, I think, yeah, it should be pretty...
You've got P prime Q over N.
Yeah.
P prime is dP dQ.
Yeah.
And you've got dP dQ over... actually, so if you factor out the P,
Yeah.
right, you've got 1 plus P dP dQ Q over N.
Yeah.
So that comes out to, because that P is factored out, you 1 plus elasticity over, no, 1 over.
Yep, this is exactly what we had before, right? 1
Yeah.
minus the, but now you've got a 1 over n here.
Right, because you have to, it's negative elasticity.
Yeah.
Right, okay.
Exactly. And so that gives us that the markup relative to price is equal to 1 over n times the elasticity. If the elasticity is constant, that means that the markup goes to 0 as n gets large, right? I was going to ask that, so maybe that's fine. Yeah, so as n gets large, the right-hand side goes down to 0, right? And so competition drives prices down to costs, and as a result, quantities become efficient. Yeah, Dave?
Sorry, what does N stand for again?
The number of firms.
Oh, okay.
Okay, just to hammer this point home, let's consider another example. Imagine that we have linear demand of this form. Then, Suel, what's the equilibrium equation in that case?
Sure.
Remember, it's given by this.
Okay, so just marginal cost equal to marginal revenue. Is that
Yep.
what you're looking for? Okay, sure. So if you have Q of P over there, then you would take the derivative with quantity. So I guess you'd have to find P of Q. So you invert that.
Yeah?
Do you want me to?
Yeah, sure. Why not? You
Okay.
can do it on the board, it's probably easier.
I could just work this one out.
Yeah. And there's an eraser too.
Okay. So and it's, okay. So demand is equal to, sorry. So QP is equal to sigma times 1 minus P over 2M.
Yeah?
So just inverting that, I'm just going to call this quantity, so just Q to make it easier than isolate for this. So I'm isolating for price.
Yeah.
Q times, or Q over sigma,
Yeah?
plus P over 2M is price, I guess P of Q. So now I multiply that by
Plus
Q.
P of...
Sorry, P of quantity? Or the
Oh, no, is equal to 1,
sorry.
right?
Oh,
You brought P over 2M onto the that
Okay.
side,
so
right? But then you've got 1 times sigma, but
I just, okay. So I had Q, I divided by sigma, and I, oh,
Yeah, you're very close, yeah.
yeah, I just screwed that up, all right. Just a moment, okay. I'm gonna not skip step. All right, so, Q over sigma,
Yeah,
and now we just, so -1,
yeah.
and I just multiplied everything through by,
And then
2m.
multiply by 2m, yeah.
is that a negative 2m now? So,
Yeah, so it's going to be 1 minus q over sigma, right? Times 2m.
times, yeah,
That's equal to p.
okay,
Good.
okay.
Okay, so now p, what's p prime?
Okay, so P prime is, well, this is just, sorry. Okay, am I finding P prime or P, or?
Well, you need
or-
p. That's important, right?
Okay.
But you need p prime. Or oh, you could you could just multiply that by q and find the marginal revenue.
Yeah, okay.
That'd be fine.
Alright, alright, so.
But the thing is that we were doing it for Cournot, so it's actually better if you find p prime, because in Cournot, right? Remember the equilibrium condition is not marginal revenue equals marginal cost. It's p plus p prime times
Okay.
q divided by n is equal to cost.
Sure, okay. Oh, right, okay. Well, yeah, that's just easier. So, well, in that case, P prime is just negative 2m over sigma,
Great.
in which case, well, I think, what was the original?
So it's p.
Plus P times Q over n, P prime times Q over n.
Yeah.
So that's just, so P is so 2m minus Q over sigma 2m.
Yeah.
That's P. Plus, so P prime is negative 2m
Yeah.
over sigma. Times quantity
Yeah.
over n.
Yeah. And that's equal to
Simple.
cost.
Yeah.
Okay, can you try
Oh.
simplifying that down and solving
Yeah,
for
sure.
q?
Alright. Alright. Okay. So, what am I isolating for? Am I?
For q.
for
Trying to
Q?
find the equilibrium quantity.
Okay, alright.
Brutal.
Yeah. Okay, so I'm gonna multiply everything through by n, so I feel like that's gonna make it slightly easier. Just, if I'm going in the wrong direction, let me know, because this is probably gonna take a bit.
If you just group all the q terms together, it'll actually be pretty simple.
Okay.
Because you see that q stuff, that's like all
This
2m
is not
over
this one?
2m over sigma. It's like got a negative in front, it's got a 2m over
Okay,
sigma,
yeah, yeah.
and then it's like 1 plus 1 over n, right?
Yeah,
So
okay.
that's not so bad.
That's not bad at all. All right. So, well, I have a, okay, Q, and I have a negative sigma 2m. So if I just take out a negative Q, I have a 2m over sigma plus
Times 1 plus 1 over n.
Sorry, I took out this term plus this term without Q. Just that's 2m over n sigma.
Yeah, but the thing is, you've got 2m over sigma already in there. You see what I mean? And so you can then just multiply that by 1 plus 1 over n.
Oh, okay. So I just factor that out as well.
Yeah.
All right, sure. All right.
And then on the other
Plus
side,
2m, because there's a 2m over here.
yeah, plus
right,
2m.
is equal to cost.
Yeah,
So Q is equal to cost minus 2m over.
well, you've got a negative, so you can just make it 2m over minus cost, right?
Yeah. Yeah. That over.
Nicely done. Exactly. Okay, so you solve that all out. You get exactly what Sue L had. And in particular, as n goes to infinity here, notice that this becomes 2m minus c over 2m times sigma, which is exactly what happens when you set this equal to cost. if you put cost there, right, you're going to get, so okay, 2m minus c over 2m times sigma. We can bring the sigma to the top, and then we get 1 minus c over 2m, which is exactly what would happen if we plugged in cost for price here. So that means that price must be going to cost, because quantity is going to what would equate quantity to that level. Okay. So again, as the number of firms increase, price is driven to cost. And this suggests a much more general result. So as the number of competing firms increases, it grows arbitrarily large, price converges to marginal cost. This is one of the most fundamental results in economics. It's sort of the foundation of the idea of perfect competition. And it's the basis of most antitrust and competition policy, which aims to try to keep the number of firms competing high enough. Now, I only did some very specific examples, but this result holds even when firms have nonlinear costs, are asymmetric, as long as demand is stable and it can satisfy weak irregularity conditions. The key is just that everyone gets sufficiently small so that their markup is small, and it fails only in silly or perverse cases. Yeah, Adam?
By like marginal cost, is it like marginal cost of like the average firm, or like the lowest marginal cost in the industry?
Okay, so you have to, in the case that firms have different costs,
Yeah.
you have to think about when you're adding more firms, what types of firms are you adding, right? So if you add a bunch of firms, all of which have high cost, then you're not going to get perfect competition. If you add firms that have sort of like a representative or average cost of all the firms in the industry, or are randomly drawn, well, then you'll eventually get enough firms that have the lowest cost, and and those will be the only ones that end up producing. Okay. So let me actually go through an example that's a little bit like what Adam just said. So suppose we have Bertrand competition, but there's a distribution of costs. Some firms have high cost, some firms have lower cost. Turns out that this represents something very similar to an auction. So what firms are going to do is they're going to set their price equal to their best guess of the cost of the second. Every firm is going to set their price equal to just a little bit below what they think the cost of the next most costly firm is going to have, assuming that they're the least costly firm. Because that's the only time they're going to get to produce, is if they're the least costly firm, right? And they're going to try to just beat the next guy the same way you would in an auction, right? And so what happens as the number of firms grow large is that there's a lot of firms, and so there's very likely to be someone who's very, very close to whoever is the least costly, and that drives prices down to the cost of the least costly guy, because he feels people breathing down his neck really hard, and he feels the need to bid very close to his cost, right? So this is another example where as the number of firms grow large for totally different reasons, prices converge to cost. So this is a very general result. So if there were not constant marginal costs, you'd need to take into account more effects, but again, you would get something that was very similar. Yeah, Bart.
But if the price converged to like the lowest marginal cost, wouldn't that drive out all the other firms?
Yes.
So like,
but it won't drive out
one firm, but it would be producing.
Well, we know in Cornell competition, in Bertrand competition, there might just be one firm. Like, if one firm has a little bit lower cost than the other one, they'll set a price that's just below the other guy to make sure they get all the business, right? And it'll be just constrained by that other guy's cost. So in general, there will just be one or maybe two firms competing, but that's fine as long as he's held down to his cost.
And
Yeah.
It's held down because if you raise it higher,
The other guy comes in. Exactly. Yeah. Maury?
What happens in this case if average cost is above marginal cost?
In other words, if you have declining marginal costs?
Yeah.
So that's a natural monopoly case.
Yeah.
And that can be a little bit tricky because the problem is like other firms, but still another firm, if they had a lower cost function than yours, they could still come in, offer a price that's lower than your current average cost. Okay, so firms in that case get forced to price at average cost, not at marginal cost. Because if they were to price at marginal cost, they'd take a loss. But they can't price above average cost, because if they do price above average cost, someone else will have an income and undercut their current price, take all of the market, and still earn profits. So in that case, firms are driven to average cost pricing, not to marginal cost pricing. And that's one reason why, like when we were studying regulation, I was saying that often competition can create average cost pricing. So that's an example. Yeah, Christian.
That's not like a reasonable application of this theorem, right? Because it says constant marginal cost.
Yeah. Yeah. Okay. Or increasing, it works as well. Okay. So this is a general rule about competition. Eventually, but not immediately, competition will drive prices to cost. It doesn't immediately do it in either of these cases, because it takes a while until there's like enough firms to fill things in. And a natural question is, how much competition is enough? So an interesting paper by Bresnahan and Race tried to get at this question. So they notice that, as markets grow larger, they're able to support more firms. If you go to a big city, there will be a lot more restaurants than in a small town, right? So they looked at a bunch of different professions and they said, suppose we're going to have N firms. How many people do we need to have in a town before it's going to have N firms? Let's call the number of people needed to support N firms capital S sub N. And then we can construct little s sub n as the number of people per firm that's needed to support N firms. Now, you could think that number should be constant, right? But that's not going to be the case if competition drives down the price, right? Because if competition is driving down the price, then people are going to make less profits when there are more firms, and therefore you'll need more people to support a particular firm, right? As a result, you should expect that the number of people per firm needed to support 3 firms is greater than the number of people per firm needed to support 2 firms is greater than the number of people per firm needed to support 1 firm, and so forth, right? Now there's other reasons why you could get patterns that are like this or that even violate this, because it depends a lot on, it could be that once there's already 1 person in town, it's easier to set up shop because you can share supplies, or it could be that the people who most love living in that town are willing to work there for less, than et cetera, et cetera. So it's not completely obvious that this is all driven only by what's happening to prices, but maybe that's a reasonable place to start. And so what they did is they found 5 professions that show up in many rural towns, and they looked at how many people there were in each of these towns and how many people there were in each of the professions. And they tried to look for the point at which S starts to level out as an indication of how many firms it takes before prices stop dropping anymore, and therefore we've sort of gotten to perfect competition. Okay, so here's a picture. So the 5 professions are druggists, tire dealers, doctors, dentists, and plumbers. And you see that so this is S sub 5 divided by S sub n, with n running from 0 to 5. So you see S sub 1 is way, way lower than S sub 5. And it starts to get closer, and most of the gap has been closed by the time you get to 3 firms. Essentially all has been closed by the time you get to 4 firms, and there's like really no difference from 5 firms. So what they concluded from this is that about 3 to 5 firms is like enough to get perfect competition. Okay, so this is a model that we've been talking about where we thought that there's just one product, there's one industry, and there's like a bunch of people, supplying this product. But as we talked about in the last class, it's much more realistic in many cases that firms produce imperfect substitutes for one another, not perfect substitutes. And so a natural question is, how does the merging of two firms, or the removal of one of the products affect prices. So when we have differentiated prices and there's multiple different products, what competition means is a little subtle, because when a firm comes in to compete, it not only like increases or decreases competition, but actually makes new products available to the customers, right? And so the simplest way to think about this is holding fixed the set of prices, just allowing two of the firms to merge with one another. And I want to consider the simplest model of a situation like this. Imagine we have firms, each of whom has a linear demand. That is, their quantity decreases when they increase their price, and when the other firm increases their price, that firm gets more demand, right? Okay. So let's consider what the optimal price for each firm is when they both have a cost of C and beta is greater than gamma. Joan, can you see how to solve out for that?
Sure. You want to set price, or you want to set marginal cost and marginal benefit. So
Sorry, what'd you say?
marginal cost equals marginal benefit. So you solve out for gamma calculator, and then
Okay, so this top equation is telling you how much demand you get when your price is this and the other guy's price is that. And this is linear demand, remember?
yeah.
So, do you remember the rule for how firms price under linear demand to maximize profits?
Why wouldn't you just solve out for your price in terms of?
Well, because you don't know what your quantity is, you have to choose your quantity and your price optimally to maximize profits, right? Do you remember what price a monopolist with no cost charges?
At marginal cost. No, average cost.
A monopoly, a profit maximizing monopoly. Yeah, halfway up the demand curve, right? So halfway to the point where there would be no demand. So if this guy had no cost, what price would he charge? What price does it take before he has no demand?
So you want to I to be 0.
Yeah.
So you subtract, so negative gamma by j minus alpha, and you divide that by your beta.
Yeah, that's right. So that would be his price if his costs were equal to 0. And then what's the pass-through of someone who has a linear demand? One half. So it's 1/2. So you would say, okay, so he's going to set his price equal to alpha plus gamma times pj divided by beta plus 1/2 of cost. And by symmetry, the other firm is going to do the same thing. Joan, do you want to come up and try to write that down and solve it? Okay, so his price is equal to alpha plus gamma pj. So pi equals I'm sort of trying to teach you guys this through these tricks rather than just doing all the math out, so you can use those on the exam and it'll speed things up. So pi equals alpha plus gamma pj over beta plus c over 2. Now, by symmetry, p and I and pj have to be the same. So you can just erase the subscripts underneath them. And now you can solve out for what P has to be equal to. Good.
If they're imperfect substitutes, why does it necessarily have to be that the prices are equivalent?
Because I assume that they're imperfect substitutes but symmetric.
Oh.
This is called symmetrically differentiated Bertrand competition. Nice job. Perfect. Okay. Okay, so these are the prices before the firms merge. If we take what Joan did here, and we beta C plus alpha over 2 beta times beta minus beta cancels. I think I might have made an example here. Mistake. I think this should have been 2 times beta minus gamma, unless someone thinks. Oh, I had her go all the way up the demand curve. It really should have been halfway up the up that, right? Yeah. Okay. Sorry.
So you just divide them.
Yeah. So anyways, it becomes beta C plus alpha over 2 beta minus gamma. Now, after the firms merge, they're going to treat the two products as one product, and therefore, because by symmetry they're the same, right? And so they're just going to have now a quantity of 2 times alpha minus beta minus gamma times P. Maury, can you again use the pricing halfway up the demand curve idea to figure out what the optimal price is now?
Sure. So you just want to invert it or get the price function?
Yeah, you want price where the quantity equals 0, right? And you want to go halfway to that, right? So what's that going to be here?
Do you want to just go up on the board?
Sure. The reason it's beta minus gamma there, guys, right, is that when you change the price, there's 2 effects. You both get the fall in your demand by beta, and you get the increase from the other guys by gamma, because we're increasing the 2 prices by the same amount at the same time. Good, and let's not make the mistake of going all the way up now, so we only have half of that, right? And then we have to add half of cost, right? So because the pass-through rate under linear demand is 1/2, right? So plus C over 2. And now you can make a common denominator of those things, right, by multiplying the C over 2 on top and bottom by
Yeah.
beta minus gamma.
Could you explain why we added C over 2 again?
Because the other one is what a monopolist with zero cost would do. And then we know that there is a constant pass-through rate of 1/2. So we just have however much the cost is. He's going to charge that times 1/2 more than what someone with zero cost would charge. This is like the trick for solving monopoly problems with linear cost. Nicely done, Maury. Okay, so that gives us this. Okay, so if you take the difference of these two things by which I did on Mathematica, it becomes 1/2 times gamma over beta minus gamma times alpha minus beta minus gamma C over 2 beta minus gamma. Okay, so why did I break this out in this particular way? Well, there's basically 3 terms here. So the first one is alpha over beta minus alpha, which is a measure of how intensely these two firms are competing. Can somebody describe to me why that's the case? Yeah, Philip.
It approaches infinity as beta approaches gamma.
And what happens as beta approaches gamma?
As beta approaches gamma, beta minus gamma approaches 0, so...
Yeah, but why does that measure the intensity of competition?
Okay, as beta approaches gamma, the products become close to perfect substitutes as one sales are being pretty much diverted to the other.
Yeah, so this is actually exactly that diversion ratio we were talking about before, right? Because this is how many sales when I lower my price do I get from the other good, and this is how many sales do I get in total, right? So that's exactly our diversion ratio, which we said was a natural measure of competition in this differentiated products case, right? Okay. This thing here is the markup that the firm had before the merger. Can someone explain to me why that's the case? Mike Galbraith? So here's the price that you had before the merger. What's going to be your markup over cost? What is the markup?
It's the
Price minus cost, right?
Yeah.
So what is price minus cost?
It'd be P times 2 beta minus gamma minus beta C plus alpha over 2 beta minus gamma. Or like...
Yeah, so the price is this, right?
Sorry.
And then if we subtract cost from that, what do we get?
You would multiply cost by 2 beta minus gamma.
Yeah.
And then put all that over 2 beta minus gamma.
And that's what gives us
and
this, right?
Yeah.
Good. Yeah.
Subtract C or C over 2?
Minus C. Because we're interested in the markup.
Okay, not.
Not how much they're going to price, yeah. Yeah. Okay, so this term was the diversion ratio. This term was the markup. And then the final part is the pass-through rate, which is 1/2. So that's exactly what this change in price is equal to. Now it turns out that those 3 factors that I just broke out for you are what matter in general. So let's focus on the diversion ratio and the markup first, and let me try to explain why those should be what matters. Yeah, Evan?
Why is pass-through 1/2?
Under linear demand? Well, we went through that in the monopoly lecture. I mean, it's just a consequence of linear demand. And the fact that the marginal revenue diverges at a constant rate under linear demand from the...
So that's only getting 1/2 with linear demand?
It's only 1/2 with linear demand.
You're not saying that it's generally...
No, it's just this happens to be, because of linear demand, the pass-through rate. But let me try to go through the logic of why, in general, this type of thing is what's going on. Okay. So these 3 factors show up more generally. Okay, so imagine that Burger King buys McDonald's, right? Now, why would this lead Burger King to want to increase its prices, Evan? Just intuitively.
Less competition.
Okay, but let's go a little bit more into the mechanics. So, like, what, what gain does Burger King get out of raising the prices on Burger King burgers?
Well, they get more money, and people who otherwise would have gone to McDonald's if they were deciding between the two, now only have Burger King to go to.
No, but imagine that McDonald's stays open, but it's just owned by the people
okay.
who own Burger King.
Yeah, because then people will go to McDonald's.
And you'll profit from the burgers that they buy at McDonald's, which you weren't profiting from before.
Yes.
Right? So now every time you sell a burger at Burger King, there's an opportunity cost associated with that. A partial burger or a probability of a burger bought at McDonald's, which you could have made a profit on. Right? And so what is the what is that? Well, the number of burgers that I would have sold at McDonald's had I not sold the burger at Burger King, that's exactly the diversion ratio we're talking about, right? And then what's the marginal profit that I lose on that? Well, it's whatever my markup was, right? So that markup multiplied by the diversion ratio is exactly what I gain by failing to make a sale at Burger King, or what I lose every time I make a sale at Burger King. The cost, which I wasn't taking into account before we merged, but I'm now taking into account now that we have merged, right? So this new opportunity cost that I face is the product of the diversion from Burger King to McDonald's times the markup at McDonald's, which is also called the upward pricing pressure on Burger King. And that's exactly what we derived in these two factors here, right? This was the markup that I was earning, and this is the diversion ratio. Okay. Okay, so the upward pricing pressure is the diversion times the markup. And this is the opportunity cost that's created by the merger. Yeah, Maury?
I had a question about the merger.
Yeah.
If you think of like the merger, like Burger King and McDonald's is one firm,
Yeah.
in other words, is it kind of a form of price discrimination to raise the price of the burger at Burger King? Like if you think people at Burger King...
Well, we could have done the same exercise for McDonald's. For the moment, I was thinking of them as being sort of like Coke and Pepsi, symmetric. One is not like better than the other. It's just that, people like one better than the other.
Okay.
That's sort of how I was thinking of that. But I guess you were thinking Burger King's slightly higher quality or something like that. Yeah. Evan?
So now there's an opportunity cost if Burger King owns McDonald's not selling for every burger sold at McDonald's. So why would they not increase the price at McDonald's?
They will as well. They'll increase both of the prices. So this logic will apply symmetrically in both places. Yeah,
This
Rishi.
also takes into account the fact that people may not buy at either Burger King or McDonald's, right?
Yeah, because the diversion ratio is not 1.
Oh, okay.
Diversion ratio is not 1 means that if someone stops buying Burger King, they may go and buy some third thing that's outside. Now, that gives us two of these terms. That gives us the diversion ratio and the markup. But why is the pass-through rate relevant? Well, we know that increased cost, we just said this is an opportunity cost of a sale, right? And what is the rate at which an increased cost translates into an increase in price? Well, that's exactly the pass-through rate, right? That's the definition of the pass-through rate. Okay, so this is the reason I keep reiterating the pass-through rate, is because it comes up in all of these contexts, and you think a merger, what does that have to do with the pass-through rate? But of course, when we think about it, really all the merger does is create this opportunity cost, which then gets passed through at the pass-through rate. Yes, so
That opportunity cost depends on the previous price.
Depends on the previous price, and it also depends on the diversion ratio between the two products.
But you wouldn't take into account like the post-merger change in the markup.
It turns out that that's not what you want to do, yeah.
So we assume the markup's constant.
No, you don't assume that the markup is constant. It's just that it's very hard to measure where the markup is going to go to. And so the right way to think about approximating it, which is exactly right in a linear case, is you look at the pre-merger markup times the diversion ratio, and that's the opportunity cost that you sort of get hit with, and then you multiply that by the pass-through rate. And the pass-through rate already takes into account the fact that the markup's changing.
And so that's
Because the pass-through rate, I mean, think about what the pass-through rate is. Like, if the markup was constant, pass-through rate would always be equal to 1. If the markup decreases as the price increases, then the pass-through is going to be less than 1. So the pass-through rate is already taking into account the fact that the markup changes as the price changes. Yeah.
So is it only stable if the pass-through is less than 1?
No. It can be stable. It's only stable if the pass-through is less than infinity. So, yeah. Okay, so if you multiply by upward pricing pressure by the pass-through rate, this gives you the change in prices, and that's exactly why we got this thing up there. Okay, so now imagine we want to get the effect of this on consumer welfare. Can anyone tell me what we'd have to do with it? Yeah, Tanner.
You could measure the loss of consumer surplus
How?
by multiplying the price change by the quantities.
Exactly. Great, Tanner. Exactly right. Because, why?
Because that measures the loss of consumers. Like
It's by the envelope theorem, right? Because, if you think of the consumer surplus, it's that little rectangle, which is the change in price multiplied by how much they're consuming. Yeah, Philip.
Is this neglecting the consumer's old part of the deadweight loss triangle that's now opened up?
Yeah, so that's going to be second order. So as long as these price changes are small.
Okay.
Yeah. Okay. So this gives a relatively simple methodology for predicting the effects of mergers. So to make a prediction, you need to get internal documents or like some studies or surveys or internet data which indicate to you something about the diversion ratio. You have to measure their markup, and then you need to know something about what the pass-through rates are. And basically, most of what the antitrust agencies do, I would say 50% of it, is they have economists trying to get documents like this and try to estimate these different numbers. Okay, so what's the institutional framework that lets them do that? Well, in the US, we talked about the Sherman Antitrust Act last class, which bans firms from making illegal combinations in the restraint of trade. But pretty soon after the Sherman Act, people realized, well, if you do that, then they'll just merge with each other, and then it'll be perfectly legal for them to collude. And so they created something called the Clayton Act, which says that firms, before they're allowed to merge, have to submit it as a proposal to the government, and the government can approve or reject the firm's right to merge. Now, why wouldn't the government just block all mergers if mergers tend to increase prices? Mike Fosca?
You have economies of scale.
Yeah, because there can be economies of scale, and the government doesn't want to stop firms from realizing there's economies of scale, which might even benefit consumers, right? If the two firms are more efficient together, even a monopoly might charge a lower price than the separated firms would charge. So like a classic example of this is AT&T claimed that if it merged with T-Mobile, then you'd be able to get reception at more places in the country, and this would make consumers better off, right? So therefore, the agencies have to weigh the benefits through those economies of scale against the anti-competitive effects that tend to raise prices. Okay. So there are many agencies that have responsibility for looking into these issues, but there are two primary agencies that share responsibility for this. And Rishi, what are those two agencies?
From the...
Look up.
No. I wasn't.
So who are in, yes, FTC is one of them.
And it's not Department of Justice.
It is.
Oh, okay.
Antitrust Division of the Department of Justice. So, and any company in the US that wants to merge that's above a certain size has to pre-notify these agencies of their intentions, and then the agencies subpoena data in several stages. So first they ask for some basic information. If it looks fishy, then if it looks fine, then they just say go ahead with your merger. If it looks fishy, then they ask for more data, and eventually they might take it to court, or they might ask the companies not to merge and say that they will take it to court if they insist, or ask them to do some things like spinning off parts of the companies that are competing, etc. They have a team of about 150 PhD economists who are in charge of analyzing these issues. Okay. This is in some ways perhaps the most sophisticated economic regulation infrastructure in the world, and it's been copied by most developed countries. So the European Union is now a major leader in this area. The UK, Australia, New Zealand, all these countries have infrastructures for doing this type of merger review. It's much more unstructured and primitive in the developing world. In some countries, there's no law against mergers, in fact. So in Peru this was true, but we helped pass merger regulation there a few years ago. In others, there's a law, but there's no infrastructure to really enforce that law. So it's technically illegal, but nobody actually is there to review. Others have some review process, but they have very little economic guidance. And a few countries have gone and really, in the developing world, really established some real infrastructures like China, Brazil, Chile, etc. Now, this is very heterogeneous across the world, and in my view, there's a lot of work in the United States on antitrust policies for much more complicated things than mergers. Like, are you allowed to make some sort of a contract that might force someone to buy from you, and so forth? And those are relevant issues, but I think even more important is thinking about what are the impact on these countries that don't have any antitrust infrastructure of adding an antitrust infrastructure. Yeah, Ming.
Does this apply to horizontal mergers as well, or is it just...
This is all horizontal.
Oh, sorry, vertical mergers.
So vertical mergers are a very different issue. We'll talk about those next class, actually. Those might actually be beneficial in some ways.
Because of the cost.
Because of complementarities and so forth. So we'll talk about that. Those are quite different, and they're governed under a very different infrastructure. Okay. So traditional evaluation of these types of mergers was based on industry concentration. And that was a sort of strange system where you had to treat the industry as if it was just one coherent product, right? So this was quite an awkward process because you had to define what the market was that you were thinking about. So there's a famous, okay, so what they did would be that they would say, okay, these two companies are merging. Let's say Blockbuster and Redbox are going to merge, right? And the question is, what is the market that they're in? Well, you might say they're in the market of movie rentals in physical locations. But then people might say, well, that's not big enough of a market because, really they're also competing with Netflix. And so then you could say all movie rentals. And so there would be a giant debate over, is it physical movie rentals or all movie rentals that's the market? And the way that they would try to settle these debates is they would start with the two products that were merging. They would then add products that were the closest substitutes for those products and that was both geographic and in terms of the type of product. So for example, if you had two hospitals merging, they would add hospitals that were a little further away from those hospitals, right? Until they reached a market where the anyone who were to control that whole market would, as a monopolist, would impose what they called a small but significant and non-transitory increase in prices, or a SNP, which is usually defined as 5% price increase for at least 1 year. Then within that market, they would measure industry concentration. Can anyone tell me how they measured industry concentration? Yeah, Mike Fosco.
The Herfindahl index.
What's that?
Measure how many firms are in there. And I believe the max is 10,000, and then they have a formula for if it increases by a specific amount, they either get more or not.
Do you remember what the formula for calculating the Herfindahl index is?
I do not remember the formula.
Yeah, so that's right. So you define the share of each firm, which is their quantity as a fraction of the total quantity, and you do the sum of the square of this multiplied by 10,000, And then basically 10,000 divided by H is sort of an approximation of the number of firms. Now from the Bresnian race exercise, we should sort of start getting worried if there are less than 3 to 5 firms. This is also related to Stigler's notion of collusion, and under the Cournot model, because the markup is equal to your price times your quantity, and your price is equal, and this is the same as price over the elasticity times your share, you can get that this, the share-weighted markup of firms is equal to the Herfindahl index over the elasticity. Now the thresholds that the government set up, from this we would say, oh, we don't really need to worry until this is about equal to 2,000, right? Because there's approximately 5 firms in the industry. They set a threshold for worrying that was a little bit less than that. It was about 1,800, or when mergers increased the Herfindahl index by 300. So that used to be the standard. Now the problem is this was sort of a mess in practice. Why was that? Well, market definition was this 0-1 thing. You know, is the market Blockbuster and Redbox, just the physical delivery ones, maybe including Hollywood videos, or does it include Netflix? Blockbuster and Redbox probably have like an 85% share in physical movie rentals, and so that would be a huge problem. But if you put in Netflix, they probably only have a 10% share, and then it wouldn't be a problem at all, right? And that just seems like the wrong question in some sense, right? Because it's not like, you know, there's one market. There are many different markets. The real question is, are these two products really good substitutes for one another? Are they the best competitors for each other, right? And that's the sort of question that diversion leads you to ask, right? If Blockbuster increases its prices by a bit, probably the overwhelming majority of people who stop using Blockbuster are going to start using Redbox rather than using Netflix as the next one, right? Because if there's people who want to get it physically, right? And so merger guide, I guess Blockbuster's bankrupt now, so it's not even relevant. But the merger guidelines issued, the most recent ones issued by the agencies, moved away from this. So basically they've guidelines that they issue about how they evaluate mergers to give firms like a sense of whether their merger is going to get blocked or not. They've had these since the early 1980s, and until the most recent revision, they did revisions about every 10 years, it was all focused on market definition. But they rewrote it in 2010, and I was pretty closely involved with that. The new ones say that don't even worry about defining markets. Just calculate this diversion ratio, maybe calculate the markups and the pass-through rates, and try to predict how much the prices will go up as a result.
Is the one we read the 1992 one or the 2010?
2010 one. It talks a little bit about the market definition stuff, but you saw there's more emphasis on the diversion.
Yeah.
And yeah. So these were designed by Carl Shapiro and Joe Farrell, who were Obama's campaign contributors and advisors during the 2008 election. And when he came into office, they were made the heads of the economics groups at the FTC and the DOJ, respectively. And they were friends of mine, and so we sort of worked on this a little bit together. Now, this stuff is very much in progress, and there will be new guidelines again in maybe 5 or 6 more years, and these will reflect, I think, some of the additional concerns that will come up in economics in the time in between then. So, in particular, there are many important concerns that are left out of the guidelines. Tanner, can you think of what some of those might be?
Whether or not the merger is to make it more efficient.
Well, so those are included. They talk about efficiencies. Can you think of some others?
Whether it's fair.
Fair.
Equity.
What does fair mean?
Whether it be fair to the consumers. Or
Well, but I mean, that's what we're trying to figure out, right? Whether it's going to like raise prices.
another one is free entry.
Yeah, so entry by new firms, that's not as much of a focus. Effects on non-price, things other than prices, like the quality of the products. is another issue, right? Effects on innovation, like we talked about in the intellectual property class. These are all things that are mentioned in the guidelines, but are not a focus. And there's many issues that don't show up in the guidelines at all. So for example, we talked about how pass-through plays an important role. That's not mentioned anywhere in the guidelines. We talked about selection in the regulation class. We didn't really talk about that with competition, but we know that monopoly could actually be better than perfect competition under advantageous selection. And so it seems logical that a merger could actually be beneficial even if it raised prices in that context, right? Some of these long-term effects, like how people gain profits. Okay, so we said that, companies that merge, they're going to be able to increase their profits. That'll encourage more people to be like the types of companies that are going to end up merging, right? So that might encourage some people to enter the industry and discourage other people from entering the industry. So that's probably an important thing to take into account that the guidelines don't think about at all. Merging could make firms too big to fail, right? And that might be a problematic issue. There's some issues about informational coordination, which you guys can look at on your problem set. In an old problem set, we talked about political power that firms might gain from merging, because they might be able to lobby the government more effectively if they're bigger, right? And many of these things aren't included in the merger guidelines currently, and I think that they're very important issues, maybe as important as the issues that are considered in the guidelines. And so I think these are always interesting things to think about for theses or research. So.